I'm like the Celsius scale ranges from 1 degree Celsius, like the 0 degree Celsius to 100 degrees Celsius, ma'am. But the Kelvin, ma'am, like the Kelvin differs from it, ma'am. It doesn't range from 0 to 100 degrees Celsius.
Okay. So next, we have already discussed about heat. Heat is a form of energy, right? And what are the units of heat? Heat is measured first thing
Ma'am,
in
joules and
Joule,
calories.
calories. Okay.
Joules.
And then
Joules.
kilocalories, yes, joules.
and kilocalories.
Okay. So 1 calorie is equal to 4.2 joule approx. You can find 4.8 as well. It's better to write 4.8 joule. Okay, 1 calorie is equal to 4.8 joule. So what is calorie? What is the definition of calorie? The quantity of heat energy that is required to raise 1 gram of water through 1 degree Celsius. It is called calorie. So what is the definition of calorie? The amount or the quantity of heat energy required to raise the temperature of
I'm not sharing a screen.
what?
Like, are you sharing a board?
Yes, yeah, okay. Can you see now?
Yeah.
Okay. So the quantity of heat energy required to raise the temperature of 1 gram of water, pure water, you can tell, 1 gram of pure water. Through 1 degree Celsius. It is called calorie. Okay. So calorie is a smaller unit, kilocalorie is the larger unit. Calorie, small unit. Kilocalorie is big unit. And 1 kilocalorie is equal to 1000 calories. Always kilo stands for 1000.
Okay, ma'am.
So now we are telling that heat is measured in calorie. Then why comes joule here? So heat is nothing but a form of energy. As energy is measured in joule, so you can measure heat as well in joule. Okay. So as we have seen, 1 calorie is equal to 4.8 or 1.8 joule. Then 1 kilocalorie is equal to 4816 joule or 4200 joule. So you can consider 4.18 or 4.2. So effects of heat in this, when temperature increases, heat, when heat is gained, when heat is gained by an object. Okay, like when body gets cooled, that is object gets cooled. So as we are writing like object, you can mention object. When object gets cooled, its temperature, what happens, students? The body is cooled. What about its temperature? Will it increase or decrease?
Decreases.
Yes, its temperature decreases. Next, increase in temperature will cause expansion or contraction.
Expansion.
Yes, that is one of the effect we can write. Heat causes expansion. What is expansion, students? Increase in case like increase in length, yes, length, area, volume, etc. These are the different cases we can see when any
This
object
can be only
increases.
ma'am, this a good example is a railway track, ma'am. If you look
Yeah.
closely while looking out of the train, ma'am, if you see the tracks, there's after each track there's little bit of distance, ma'am. Due to in summer the iron expands, and if there's no space for it to expand, ma'am, it's going to go like this, ma'am, which can cause the accident, ma'am.
Yes. Okay.
And ma'am, and then in summer it contrasts back where it was.
Yes. So even the wires of poles, you can see they are tied very loosely, isn't it?
Yeah,
Because
ma'am.
due to expansion and contraction property in winter seasons, in winter and summer.
Okay, ma'am.
Next, heat also causes change of state.
Yeah, ma'am. Now, if you heat water, ma'am, it's going to get
vapor, like from solid to liquid, liquid to gas, it can change.
Oh yes, ma'am. Solid to liquid, liquid to gas.
Done?
Yes, ma'am.
Next, we can see applications of expansion of solids.
Ma'am?
Ma'am, railway tracks.
Ma'am, ma'am, the best example for like, ma'am, the solids expands on heating, it means, ma'am, Gravesands ring and ball game will come, ma'am.
What?
Ma'am, Gravesands ring and ball game. Ma'am,
ring and ball?
Ma'am, wait, ma'am, I'll send that picture in chat box, ma'am.
Okay, so the applications like supposed to fix in case of wooden cart wheels, like while bullock carts and everything.
Ma'am, that traders use, ma'am, they have an iron rod, ma'am. Ma'am, they take a bigger size of the wheel, ma'am, and heat that iron rod and keep it on the wood, ma'am. And ma'am, they hit, and ma'am, they actually let it dry, ma'am. So when it cool, ma'am, it's going to contrast and stick on the wood.
So if you want to fix iron rim on a wooden cart, so we will heat the iron ring so that it expands, and then after fitting, after cooling, it will again contract to that particular shape. So you can write that in an example, fixing of iron. What is that?
Fixing of
iron rim on Wooden cart wheels. Okay. Next, we can see reverting of metal plates. Okay. Next, gap between the railway tracks.
Gaps between roads. In roads, there are some lines, right? Especially in concrete roads, they
Hi,
make
yes,
some
ma'am.
lines because in summer they expand.
Yes, ma'am.
Concrete roads. What
Yeah,
lines?
ma'am.
Like between the concrete roads, they make some lines. They cut some
Ma'am,
lines.
made out of metals, ma'am. Made out of metal.
Okay. Yes, yes.
Ma'am, I
Ma'am, then
sent you that picture, ma'am.
can you send it to everyone so everyone can view?
I'll show you. Don't worry, students. Can you see this?
Ma'am, it's too small, ma'am.
Now,
Yeah, ma'am.
clear?
Ma'am, like their side one candle is there, no, ma'am. Ma'am, first the ball can go easily, ma'am. Ma'am, but next when we hit the ball and when we try to, ma'am, like pull it through the ring, it will not come, ma'am, because it heat, ma'am, like it expands on heating.
Hmm.
Yeah, ma'am.
Next, a small gap is left between the blocks while laying the concrete roads, as somebody told, like Karthik told, Hari Karthik. So you can write a small gap is left between the blocks while laying the concrete road. Okay. Next,
Without that gap, ma'am, that the whole bridge at summer will collapse. No matter how many pillars you keep below it.
what?
Ma'am, I told that, ma'am, if that gap is not there, the bridge will automatically collapse. In also not caring how many pillars you added.
Hmm. Next one is a sag is left while laying telephone and electrical lines.
Ma'am, what is a sag, ma'am?
I'll show you. Everybody knows this, but you don't know what exactly sag. Just before I told you, like they are tied very loosely around the poles. So in between the poles, how the wires are tied, students?
Ma'am, spirally.
I'll show you. They will tie loosely this way. This is called sag, the looseness.
Yeah, ma'am. Ma'am, in summer, ma'am, if you see, ma'am, this is going to be like this, not like slope like this, ma'am.
Okay. Next, we can also write that special glasses like Borosil or Pyrex glasses. So in that, to avoid the breaking of ordinary glasses when hot water is poured, so it is also made up of same phenomenon.
Ma'am, in the back of the cars, ma'am, there will be some kind of metal, right, ma'am?
In back of cars, which metal, students?
Ma'am, on the glass, ma'am, on the back glass of some cars, there are some kind of lines like metal, ma'am.
No idea about this, students. On the back side of cars. So I never saw those. Okay, so next, bimetallic strip. Do you know what is bimetallic? Bi means two, metal means two metals are used. They are joined together by reverting technique. So how a bimetallic strip is created. So for this, you can tape. If you want, I can show you how we can make this bimetallic strip.
Yeah, ma'am. Bimetallic strip, ma'am.
Can you see here?
Yeah, ma'am, we can see the image.
Yeah. So the brass and steel here, they're first they are heated and then cooled. This is a bimetallic strip. So in this, the principle involved is unequal expansion and contraction of different materials on heating. When heated, brass expands more and its greater length puts out on outside of the curves. Can you see? Brass expands more. And when you cool, brass contracts more. And its shorter length puts on its side. Inside, shorter length is shown. When heated outside, longer length is shown. Can you see? So brass and steel are the two metals we are using. When you are heating two metals, brass expands more than the steel. So you can see the outward expansion here, and the brass is the one which contracts um, more than steel again. So here shorter length is shown through the inside one. Okay, so this phenomenon mainly it is used in fire alarms, thermal switches, in refrigerators. Next, we can use as well in bimetallic thermometers, etc. Okay, what is the principle involved? Principle involved is the unequal expansion and contraction of different metals on heating. Clear?
Yes, ma'am.
So if you consider brass, so brass expands more. And its greater length put it outside of the curve. So when you heat the outside curve, which is the one brass, and when you cool, the inside curve is brass, because here the brass is contracting more faster. Clear?
Yes, ma'am.
So examples which we can consider examples, it is mainly used in bimetallic strips, are used in fire alarms, thermal switches, such as those.
Ma'am,
Yes.
now what are thermal switches?
The switches.
Ma'am,
Hmm.
Okay, ma'am.
Clear? Next important definition is specific heat. So this you are going to solve numericals as well on this, and specific heat is very important. Specific means, what is the meaning of specific, students?
Ma'am.
Ma'am, like a fixed quantity, ma'am.
Yes, ma'am.
Particle.
Like we are talking about something exactly,
particular
right?
thing, ma'am.
Perfectly, yeah, particularly. So here specific heat it is talking, means the amount of heat required for a specific for a substance specifically, right? So the definition comes here is the amount of heat energy required to raise the temperature. So they are raising temperature, but we have to tell it as specifically, right? To raise the temperature of a unit mass of substance. Here, what is mentioned, students? Unit mass you have to consider. Unit mass of substance. So that unit mass, like how much you can call it as, let's say 1 gram. Unit mass of substance, which is 1 gram through 1 degree Celsius. Then what is calorie? See the difference between calorie and specific heat. Calorie means to heat required to raise the temperature of 1 gram of pure water through 1 degree Celsius. Whereas specific heat is 1 gram of substance through 1 degree Celsius. Okay. And it is denoted by S
It's capital S.
No, small s it is. Now, from the definition, what are the units you can give for specific heat, students? Heat required by 1 gram of substance. How much heat? By 1 degree Celsius, right? So how can I write? Heat required means 1 calorie heat for 1 gram of substance to 1 degree Celsius. Can I write like this? Yes. So it gives you 1 calorie, gram inverse, Celsius inverse. Both are same. If I want to convert into joule, how can I write 1 calorie is equal to 4.2 joule. So 4.2 joule, gram inverse, Celsius inverse. And specific heat, there are values like the specific heat values differ in each and every substance, like based on its state. Suppose if we consider specific heat of ice, so it will be 0.5 calorie, gram inverse, Celsius inverse. So the same ice, if it is in liquid form, that is in water form, so it is 1 calorie, gram inverse, Celsius inverse. If it is in the form of steam, its value is 0.47 calorie, gram inverse, Celsius inverse.
Thank you, ma'am.
Ma'am,
Hmm.
ma'am, can we have a quiz, ma'am? Ma'am,
Yes, let me complete first. Done, students?
yes, ma'am.
Still Karthik is writing.
No, ma'am, I'm done.
Okay. So next last topic after this, we'll be having a quiz. Next is anomalous expansion of water. So we know that generally water expands on heating and it contracts on cooling, right? Yes. Suppose I am considering water at 0 degrees Celsius. Okay. So water at 0 degrees Celsius, if it is heated, water at 0 is heated, then it contracts and its volume decreases from 0 to 4 degrees Celsius. It contracts and volume decreases from 0 to until 4 degrees Celsius, the volume of water decreases. Okay, it means At 4 degrees Celsius, water has minimum volume. If volume is minimum, what will be its density, students? And density, how volume and density are related? Inversely related.
Ma'am,
If
ma'am, yeah, ma'am,
volume
ma'am,
is
like,
minimum,
ma'am, like,
density,
ma'am, density means amount of material in an object, and volume,
see, density is
vo-
equal to mass by volume. It is the formula,
yeah, ma'am,
right? How
yeah,
they
ma'am,
are
yeah, ma'am,
related? Inversely related.
yeah,
If
ma'am,
density
inverse.
is more, volume is less. So until 4 degrees Celsius, the volume decreases. So it means at 4 degrees Celsius, water has minimum volume and maximum density. Then from 4 degrees Celsius, like you're still heating the water, then as the temperature increases, as the temperature increases, volume also increases. This is the anomalous expansion of water. This is the anomalous behavior. Okay, when water at 0 is heated, it contracts and volume decreases from 0 to 4 degrees Celsius until 4, and then it increases as the temperature is increasing.
Okay.
So because of this behavior of behavior of water, so generally aquatic life can survive even in the frozen ponds in cold countries. Okay, still if you see the temperature is above 0 degrees Celsius outside, inside you can find 4 degrees Celsius. Okay, so in case of the central portion regions, so where outer you can find 0 degrees Celsius, where thin layer of ice is formed, and inside there is 4 degrees Celsius only. So due to that, aquatic life is supporting.